Okay. Describing data. Here we deal about the different types of data, different types of variable, and how to represent the tables and graphs in terms of the represent the data and its variability. Types of data. So it has three types. One is the qualitative, and the next one is quantitative, and another one is called as a ranked data. So generally, before we go into types of data, so data is a collection of observation or scores on survey or experiment. So using this data, we can able to perform many useful information to the management. I mean data science management. So first one we look into the qualitative data. So qualitative data will represent the service. For example, you can represent the property of how the particular information is useful to the user. So generally we take the feedback. It will be the one of the example for the qualitative data. So generally we take survey. The icon which is told as excellent for a best one, good, medium, poor, and very bad. Or we can have a rank from the 10 to 1. So 10 is best, and 5 is fair, and 1 is the poor. So which is not a actual value, but it is represent the some sort of information about the quality concern about the data. Second one is a ranked data. So we know what is meant by a ranking. So ranking is not a number, or it's a grade of the group of people. So it is not about the collection of individuals. So it has, for example, we have 10 people in the right side, we have the one day player ranking. So the rating will be have in the right side, which will be different score. But what the ranked data will represent: the first one Babar Azam, second one Virat Kohli, third one Rose Taylor, and the third rank was shared by the Rohit Sharma as well as Rose. So this is called as a ranked data. Even the actual information was something different with the group of people, but the ranking will able to weighted average or weighted information between the group. So that is called as a ranked data. And the third one is a qualitative data, which describe about the different number of weights that represented with the amount for general numerics. For example, we can say weight of the uh, any uh, any object. For example, you take about the vehicle car. So car normally that will be around 1 ton or 2 ton, or we can say buy a things from the supermarket. So we can 10 kg, 100 gram. So these are the numeric data, numeric information, which will be bring into the qualitative data. Next, we move to types of variable. So we have three. Majorly, we have a 7 types of variable. So generally, variable used to store a value that hold a different values on different times. For example, starting of a program, we can say a equal to 5. Then we can able to add an expression like a equal to 5 plus 5. Then after sometimes we can say a equal to 15 plus 5. So the variable is called as a, which used to store the value, but it hold the value of the different on different times. So we have majorly a discrete variable, continuous variable, approximate variable, independent variable, different variable, as well as the confounding variable. We can see one by one what it is. So a discrete variable is nothing but is a number or is a numeric or a discrete value which is able to give a value directly to the user. For example, you can find the height of students. So height of children, we can say what is the height. So 120 or 100 or 88 or 28. That's called as a discrete value. So there is no change on discrete value. It is directly proposed to the what the observation it will gives. Second one is a continuous variable. So the stopwatch will be the best example for the continuous variable, where it will start from 0 and it will move on as well as infinity whenever we need a things. There is no restriction for the end of the particular continuous variable. Third one is the approximate variable. Very simple. It's converted to the nearest integer or nearest value, which is called. For example, you can say 5.7 equal to 6. It will be the approximate value. The independent variable, where the investigator are not influenced by any other variable. So for example, we can able to see that the right example will be the independent variable: car, bike, bus, train, and the metro station, or everything will be have individual. So these particular information we have, objects are the variable which will not depend upon the any other thing. For example, you can say weight is another one example. Dependent variable, where one variable as influenced by the other. For example, you can travel a bike or a car. So based upon speed as well as the accelerator, I want to see the speed. The speed will be based upon two things. One will be the how much accelerator we are able to give, and what is the gear we are moving. So based upon these two variable, the speed was fixed by the machine. So that is called as a independent variable. Okay, for example, we can say whoever have the have the height, they can able to jump more. So the jumping height can be described by the what is the height the particular person will have, that has influence. That is called as a dependent variable. Then next one will be the observational study. So it is a relationship between the variable or the experiments. It will be conducted in the laboratory. We can able to find the value from the through experiments. So that's what the observational study. Then the last one, the confounding variable, which compromise the interpretation of study. For example, something which is not able to achieve or something in the extraordinary variable we can call as a confounding variable. For example, the height of people will normally have to 6 feet. Suppose we find some people have say 8 feet or 10 feet, that is called as a confounding variable. So it is above the limit, or another way we can call as a outlier variable, that's called as a confounding variable. Next, we move to the describing the tables and the graphs, how to represent the data. Here, the tables, we have five major things. One will be we can build the frequency distribution, outlier, relative frequency, cumulative frequency, as well as the how to represent the qualitative data into the frequency layers. So here I have the list of one table which has the 40% height. So this is the given data. So here we can able to found the how the frequency distribution can be built. So generally frequency distribution we can show into the in terms of table, and what are the occurrence in the table will be, what are the observation we can able to hold in the table. So here we can see what this is one group of people for 40 people, we can list. Next one, I going to build a frequency distribution. So right side, I just bring the data into the right side, and I can able to sort it out. So 128. So my frequency count will be 1. 129, 1. Like that, 133, 2 times, 2. 134, 2. And 176. So you can see, so we have a 40 variable as a data, and the frequency count will be the repeating, sometimes unique, sometimes we can have three. So it is not about limited, you can be able to change whenever based upon the data, the frequency or count can be changed, but the total number of frequency will be the 40. So 40 data will be available in the table, and 40 frequency count is also available in the answer. So this is where we have to found the frequency distribution. So what the frequency distribution will gives, it gives the overall view. For example, there is no repetition on the data, or every data is repeating. Suppose we have more number of 2, so we can say every data is repeating one time. Suppose have a one same data will be have 5 or 6 or 7. So whenever we increase that, a group of same amount of repeating data we can able to get. So this type of information we can able to get into the frequency distribution. Then how the frequency distribution can be built furthermore. So each we can able to split the particular frequency distribution in terms of the classes. For example, we have a 40 data, we can split into the 4 groups. So how do you fix the 4 group? So we have set of guidelines for this. First one, every frequency or every observation must be fall into the at least one of the class. Then we can have each frequency has fall into the one class. Then the class interval are equal. For example, we can divide by 4. So first 25, second 25, third 25, and fourth 25. Like that we can able to split. Then each class has the upper limit and lower limit. The total frequency normally we used to split as 10 classes. So we can see one example for the first year. First one, how to construct the frequency distribution. So here total frequency distribution have 50 numbers. So these 50 numbers, we can able to construct the frequency table. How the previous slide we can see how to construct the frequency distribution. Now we are taken about the range. So that means 1 to 5 or 6 to 10, like to tell, we can able to construct the range, and I can able to get the value. So first one, what they do, find the range. So range is equal to large value minus small value. So in this table, large value is 50. So this is what 50, and the small value is 1. So we got 49. So 49 is the range. Second one, find the class interval. Formula is class interval equal to range by number of classes. So 40. Okay, sorry. This is actually 49 by 10 equal to 4.9. Okay, this is called the class interval. Then round the nearest interval, the 4.9 will be converted into the 5. Then determine the lowest class should be begin where. So the first one, so that will be the 1. Then determine the lowest class will be ending, so that will be 5. So 5. Then determine list all classes to include the observation. So 1 to 5, 6 to 10, 11 to 5. So total things you can able to found. Then you can see 48 will falls into this class, 20 is fall to fourth class. Like that you can split the individual, and you can able to get the number of how many individuals we can able to. So you can take the total, all observation you have to include the classes. Then you have to find the total number of this frequency will be 50 and this available will be 50. So we have to construct the frequency distribution table using this method. Next, outlier. So outlier, as you know, a extreme value from the given observation. So you can see here the example is 26, 31, 28, 25, 34, 31, 2, 30, 108 and 2. So here the lower limit will be called as 2 and higher limit will be the 108. So this 2 layer is called as a observation. Then next one, relative frequency distribution. Again the same model, we can able to construct the first 2 columns as range as well as the frequency. It was as usual the first whatever we found the frequency distribution. Then we can find the relative frequency. So you can see 7 divided by, that is the frequency 7 divided by total number of frequency 50. So 7 by 50 we can get 0.14 will be the relative frequency. Then next one, 6 by 50, 0.12. Again 4 and 3 and 5 and 1 and 2. So you can find the relative. So the sum of the relative frequency must be 1. That means one particular part of class, how much impact will have the relatively with the total. Okay, that will be given to the relative frequency distribution. Next one, cumulative frequency distribution. Again the same, the first 3 columns are same, class, range and frequency we has. Then how to construct this cumulative frequency is equal to sum of current class with the all lower classes will be, it will call as a relative. For example, we can say 7 is with the current class, the all this sum will be called as 50. So sum of first class to 10th class has, we can call as a percentage will be the 100. So next one, we can take 7. So sum of second class up to 10th class, we can say we get 43. So 43 percentage used to get us here, 86 will be the percentage. Then 36, 30, 24, 24 like that we can give the how to calculate, and the relative frequency how much it is going to get reduced will be given here. Okay. Then the qualitative data distribution. So the qualitative data we can get yes or no, as well as or we can get the feedback, and we can represent the table as survey as yes, number of children will be 14, no means 26 and total will be the 40. So this way we can represent the table. Even we can able to construct the cumulative frequency for the qualitative data as usual the same. So you can get a frequency 8, 11, fair, good, poor. So we can take 40 people and we can get number of representation, then we get frequency. So same way 18 by 40 will be the relative frequency, 40 will be the cumulative frequency. So generally in the it is not exactly we will get as usual the quantitative data is data representation, but we can get almost equal value to the qualitative data. So it is able to applicable. Okay. Next one, represent the data in terms of the graphs. So we know graph will be the one of the useful method representing data in the all times. So whatever we have a graph, that we can easily mention that the graph value. Okay, so here I have a class. So whatever we have a class value and frequency. So this is called the histogram. So we can have a distribution into the numeric value a series of the vertical bars. So the left one will have the class, I mean the x value. So we have a class, and here we can have the value, and it will be represented into the histogram. Next one, frequency polygon. So this is the how much it is impacted with the consecutive polygram. So first we construct the histogram, then we construct the frequency line as polygon, then we can fill the polygon value into the third one. So same data set we can able to use. Then stream and leaf display. This is another way of representing the data. So he, instead of for you can say here 50 variable it is there. So we will take so many representation or so many memory size will be representing the data. So the same thing we can use the stream and leaf method, which you can able to find the directly value to the using the simple way. So here you can see example we have the 5 columns, and totally we have the 5 2 4 6 8 10. So 50 numbers will be stored into the things. So you can see the range starting from 0 to 50. So that's also a 50. So what the stream lift display have two parts. First one stream and the second one leaf. So you want to construct a value, you can take a value from stream as well as the leaf you have to get. Okay, so for example we take about the 48. So 48, the stream will be 40 and the leaf will be 80. So we get 48 will be the value. Same way, so we get 20. So 22 will be the stream and 0 will be the leaf. So we get about 20. The same way, how to construct this table is you can split into in terms of tens. So zeros, tens, 20s, 30s, and 40s. Next one we can construct the leaf. So stream will be split into the terms. For example, all value from 0 to 10, 0 to 9 it come from the stream. All value from 10 to 19 will come from the 1. All value from 2 to 29 it come from this one, like that. So now there's first we take 48. So 4 8 is 48, 4 9 will be the 49, 2 0 is called 20, 2 7 equal to 27, 2 4 equal to 40. So now we can represent the 50 digits plus 5. So only 55 digits will be represented. But here we can represent the 50 into 2. Almost we can represent the 100 digits. So we can able to save the data or size will be the 45% of the things will be able to save easily. So that's what the stream and leaf display. Then types of shapes I have. So normal curve, we start with the lowest and miss to peak and getting to reduced. So bimodal curve, we have a two peak value. The peak value need not to be equal, but it can able to has the two peak value nearest to that. That model we can call as a bimodal curve. Then positive scored curve will be the initially the peak value was high and starting whenever go for end it is getting slow. Actually it start from peak and it is getting reduced one by one. Negatively skewed, initially the value of the curve will be the low, amplitude is low, and whenever go for end the peak value will be available. So the positive skewed peak value available in the left hand side of the total curve, negative skewed value the peak value available into the right hand curve. Okay, so qualitative data, so again you can have the represented we can terms of the graph. Then we can see describing about data with average. So we can three things we can able to identify: mode, median, mean. Okay, and the qualitative data for the ranked rows. This thing we describe about the data and averages. So mode is a the most frequently occurring data or information and the peak score of the particular value. For example, we have data. So 34 to 34, 23, 7, 23, and 6 will be the given data. So the peak value is 34 is called as a mode. Then we go for a bimodal mode. So where we have a set of data here, we can say highest two value will be considered as a mode. 34 as well as the 37 will be the highest. I mean bimodal mode. So whenever we go for a bimodal mode, we represent two mode. Whenever the simple mode, we can represent by one value. Okay. Next one, median. So median will be the mid value of the particular given data. So what we do, we have a data, then we order we can sorting the data into this order like lowest to highest. Then we find the middle value is called as a median. So now we can see seven variable in the available, sir, 7 data available in the list. So we can say middle will be the fourth variable we can able to write. So but they see the second one. So we have 2, 4, 6, 8 variable it is, value it is there. After we ordering the data, so we cannot able to find the middle value. So what we do, so we can take the middle of the two things. So 4 and 6, then divide by 2. The 5 is called as a median. Okay. So median is not a mean. So median is different. Mean is different. We can see next mean. Okay. So mean is a nothing but as a sum of all score divided by the number of score. This is the formula for mean. So mean is equal to sum of all scores divided by the number of scores. Here we can see example, the given input data will be 2, 6, 8, 1, 7, 5, 10. Then we can say sum and 7. So we can get the 5.5 will be the mean value. So mean value is not be equal to the mode or any other value. So mean is different as well as the mode is the different. Okay. So when go for a qualitative data, so data, it is not, we cannot use exactly what in the quantitative data, but the median as well as the mode we can able to use for the qualitative data to get some information about the things. Okay. Thank you.